Thank you. Good morning. My name is Max Lemaitre. I'm very happy to be here to present DeltaR detection on behalf of our Florida-based team. My coworkers include Dr. Thierry Dubroca, who's been involved with this technology since it was invented. He also very ably brings his MBA experience and training to our team. We also have Dr. Rolf Hummel, the inventor of the technology and our scientific advisor. He has over 40 years of experience in applied optics and spectroscopy. So due to the very tense global political climate and terrorist activity of late, this has really brought a high risk to human life and public infrastructure, and as a result, the public has demanded of our governments to find and implement new technologies to mitigate this risk, and that's the business that we're in. I want you to imagine that the government has decided to implement a new technology for explosives detection at airports. So just imagine a black box. So now after you've waited in line, you get to the front, you take your laptop out, take your shoes off, pull out your toiletry bag. Now you got to take all this stuff, you got to put it in this new black box to detect explosives. Now what I want you to do is imagine the line going all the way back out that security checkpoint. And those of you that travel, I'm sure, are grimacing at this right now. But what if instead there was a technology that could plug directly into existing infrastructure, was invisible to the customer, needed no operator, could detect a broad range of explosives with very few false positives, and do so without increasing the line at that security checkpoint? Now we believe that this would be extremely valuable to the customers in our market, and we believe that we have such technology. So let me give you a brief overview of that. Our patented protected technology is based on differential reflectance spectroscopy. Simply put, we shine broadband light from the deep UV to the near visible. It's reflected off of the surface. It's collected by a custom set of fiber optics and optical elements that transmit that light to a spectrometer. The spectrometer parses that light into spectroscopic data while preserving an image. That's then passed on to proprietary software that uses pattern recognition to analyze this data and then determine what the chemistry is at the surface. Our rollout product is an automated carry-on baggage detector, as shown. So it can be made in one of two ways, either as a modular unit, as shown here with its own conveyor belt, or as a retrofit unit to go directly onto existing X-ray baggage scanners. Now, because of the speed at which we can scan, it's not part of the bottleneck, so it in fact doesn't add any time to current X-ray analysis. Now, before I tell you this is a perfect product that's got everything solved, we do have a couple challenges. Those are the limit of detection and software development. Now, the things that we're doing to correct this, we currently have a 500 nanogram sensitivity limit. That's one order of magnitude off from TSA's requirements for certification. We believe that through our next prototype with some increased optics and some changes in the hardware that we can achieve that. Secondly, through software development, we've actually been partnering with a very talented team at the University of Florida that specializes in pattern recognition and software, and we actually have 2 pre-approved grants through DHS that address this subject. Now, what is our value proposition to our customers? We have both operational and financial benefits. On the operational side, it's very few false positives. This technology is complementary to what exists today. It's different physics, so we can either be a primary screener of baggages, or we can also work with the ion mobility scanner that's currently in use today. It's also, the throughput is really where we have an advantage. We can scan very, very quickly. And finally, we detect a broad range of explosives. In terms of financials, 10x reduction in operating costs. We don't have an operator. Longer product life cycle, better customer experience, and finally, it's integratable directly into existing infrastructure. This is very important. We don't need new procedures for TSA. It's very difficult for them to come up with that. So we can go right with what exists today. Market overview. Now, this is a 3-tiered market, the largest of which is the US market. Now, this is a single customer, highly regulated market, completely controlled and funded through TSA's budget. Now, TSA is actively involved in the development of these new products. They have a very rigorous certification standard, but as a reward for putting up with that, they're much less price sensitive than some of the other customers that we can go after. The European market, highly segmented, lower barrier to entry, which comes from the fact that the purchasing decision is a little bit more flexible. Finally, there's an emerging private securities market. Now this means hotels, stadiums, shopping malls, high risk areas with lots of people going through. The advantage with this market is that we have a very versatile platform that we can custom to tailor to these markets and these customers, which currently don't have that option. I'm not going to talk too much about our competition, but below our own scanner at the top, there's several competitors that are at some level of deployment with TSA. These all have merits, but there's two things that they can't do that we do very well. The first is that we have an automated decision making so that we don't need an operator. This is something that TSA has specifically said that they do not want. Secondly, we are a primary screener of every single carry-on bag. This is not possible with any other concurrent technology. Marketing plan, we have a three-tiered market, so we have a three-tiered marketing plan. The first is direct sales to TSA. Now in order to do this, we have to be TSA certified. To get TSA certified, we have these pre-approved DHS grants, which give us one big advantage. It gives us access to certification standards and TSA personnel to help us guide us through this regulation process, which can be very complicated. Once we get to that point, we'll make 1 to 5 prototype machines for them to bring to field testing and get to that purchase decision. Once they do, our revenue model is direct sales to them with service contracts as an additional option. Another option for us is distribution through a market leader. Now in that case, we would leverage our relationships that already exist with L3 and Smith's Detection. Now this really gives us a nice advantage that it lets us focus on our core competencies as a company, which are engineering and product design. And in this revenue model will be through technology licensing and engineering consulting for future developments. Finally, there's the auxiliary sales to the private securities market. So here we really get a chance to combine the distribution models. We can use a distribution model for areas where we don't want to get into directly, but we really get a chance to take our engineering and product design skills and train or adapt our product to various customers and really tailor our versatile platform to the needs of these customers, and we can have lower price point products in this market for those customers. Now here's our timeline. On top you see the time, and then bottom is the money that we've either spent or that we're going to need in the next 18 months. The research and development timeline, you see we've been through several prototypes. We're now at the point of working further on that software development, moving forward and getting to a commercial grade prototype that we can give to TSA for certification. The financial timeline, we've been through several government grants and university contracts. We had a patent issued in 2008. We have an option agreement signed. Next step would be the license agreement, and as a secondary plan, if the DHS grants don't go through, we're still looking at seed funding. We need to hire a few engineers to get us from the prototype we have today to a pre-series prototype for TSA to evaluate. Our financial projections, so we're making a few assumptions in these. First of all, for simplicity, it's a single product plan, just the carry-on baggage scanner, and a single customer, just the direct sales to TSA. We assume we can make this for $50,000 or less. This is based on the current prototypes at $150,000, and then our pre-series launch is projected at $80,000. We believe with scale-up we can easily get to $50,000. We're assuming that within 18 months we will at least started the certification process with DHS and TSA. We're also assuming 10% market share. Now what that means is 10% of the total explosive detection market. We believe this is possible because we are in a position to go after the entire market for screening all carry-on bags. Finally, we're benchmarking the first couple of years off of Smith Detection's Ion Mobility Scanner. So here are the projections. The important thing to note, $200,000 as a unit price. This is based on a 2-year return on or 8 years of return on investment based on a 10-year product life cycle for the Ion Mobility Scanner. So after 2 years, TSA breaks even with our product and has 8 years of return on investment. We break even after 18 months of the first product sold. We have about 20% profit margin, which is slightly exceeding the market leader. And it also gives us, we have a large research budget so we can expand on this platform. Finally, DeltaR detection, what we envision is a product that is applicable over a large range of applications. It's really a platform, and we really are excited about developing this and bringing it to market. And I'll take your questions. Thank you very much.